Here we are on part 3. The command is solve. Problem number 3, 2 sine squared x minus sine x minus 1 equals 0. And notice I've added a restriction. I'm only allowing for answers between 0 and 2 pi. So that's once around the circle. So that will avoid using that technique with all the n pi's or 2 n pi's or n pi's. So let's look at how this one turns out. These trig equations can take twists and turns, and I can't show you every single scenario that could come up, but I will be there to guide your tutelage tomorrow should you come upon a twist that you can't solve on your own. The twist or the turn that this one takes is to solve it. It's like a quadratic function. It is a quadratic function, sort of similar to that one. So if I represented sine x as just x, it would look like this. So we could factor that, and we're going to solve quadratics either by factoring, completing the square, or the quadratic formula. In trig class, I think I've always seen them factorable. It's possible that we'll find one that isn't. So let's go ahead and factor this one straightforwardly. So thinking FOIL backwards, first times first has to give us this expression. So 2 sine x has to be in the first position in this factor and in the first position in that factor. That times that gives you, oops, it does not. Then sine x has to be in the first position, not x. Now 2 sine x times sine x will give you 2 sine squared x. Last times the last has to give you -1. So to get a -1, one of them has to be positive and one has to be negative. Let's see if that is the correct one to generate this with the inner and outer product, because that's the part of FOIL. We took care of first times first and last times last. But the O and the I, or outer and inner product, have to be addressed. And if it doesn't work, we'll have to change one of the others. So let's see. Our outer product is these two things multiplied together, which gives you 2 sine x, and the inner product minus 1 sine x. So what's 2 sine x minus 1 sine x? It is a positive 1 sine x, and we needed a negative. So we have failed to factor this correctly. So let's try. The only other thing we can try, this times this has to be -1. But what if this side is positive and this side is negative? Now when you check the inner and outer products, you get -2 sine x, positive 1, which is a -1 sine x. So this is the correct factoring. The whole reason we factored is because when you multiply something times something and it gets 0, either this must be 0 or this might be 0, or both. So we're going to take each factor and set it equal to 0, because if either equals 0, the whole thing equals 0. Solving this one first, I move the 1 over and divide by 2 to get sine x is -1/2. And over here, I move the 1 over, I get sine x equals 1. All right, so are we done? No. So we have to find what angle has this as its sine. Oops, I lost my variables. All right. What angle has this as its sine? So to do that, look at the unit circle. And again, we're restricted between 0 and 2 pi. So let's see. We want the second coordinate to be a -1/2. So second coordinates are negative down here. So let's try this one. If we go over or back square root of 3 over 2, and down minus 1/2. Does that give us a second coordinate of negative 1/2? It does. So we found 1, and that's value is 7 pi over 6. All right, so we're only allowed to look in one circle, so let's see where else we can find that happening. Does it not happen over here as well, where we go over square root of 3 over 2, and the second coordinate goes down 1/2, so that is 11 pi over 6. So we found two answers. We can't add another circle to each one, another 2 pi, because that would take us out of the acceptable values for the answer. So 7 pi over 6 stands alone and 11 pi over 6. And then we had this other side. Where does sine of x equal 1? That's one of our monkey maths. So is it up here? That value is here, here, or here. This value here is 1, 0, so the second coordinate is not 1. This one is 0, 1. Good, here it is. Here's 1, so that's pi over 2. And checking over here, negative 1, 0, nope. And 0, negative 1. So it seems to only happen at one spot, pi over 2. So putting them all together, I get 7 pi over 6, 11 pi over 6, and pi over 2 are the solutions to that equation. All right. When I just want to finish with a caution, and that is sometimes our trig equations have not sine, cosine, and tangent, but secant, cotangent, and cosecant. So suppose after you've factored or after you've solved, you got an expression like this. I just want to mention a little technique that will help you get through. Because we're more familiar with sine, cosine, and tangent on our unit circle, could we not change this so that it's not cosecant, but it's the reciprocal of the cosecant? It's sine. So we can actually take the reciprocal of this if we take the reciprocal of that. So I'm going to flip this on its head and flip this on its head, and 1 over cosecant is sine. So I'm much more familiar with working on the unit circle with sine than I am with cosecant. So this is a little trick of our trade when we're solving trig equations. That did not show up in the 3 examples that you saw tonight, but it could come up tomorrow. So a little heads up there. And there are some other ins and outs that I will help you with when the time comes. All right, our trig class is over. Take these notes and bring them with you, and I will see you bright and early. Bye for now.